Okay, welcome to our lesson on Lenz's Law. Let's get straight into it. Now, Lenz's Law is a law of opposition, if you like. And basically, what it says is this. If we change, or if there is a change in the flux through a coil, so if there is a change in flux through the coil, then that will cause the coil to induce a current. In other words, a current is created in the coil and that current creates its own flux, which opposes the change in the flux that we initially caused. So the coil induces a current which creates a flux and that flux that's being created or induced is going to try to oppose the original change that we caused. So we can probably even simplify this down a bit. So, if there's a change in flux, if there's a change in flux through the coil, that will lead to an induced current in the coil, an induced current in the coil, which creates its own flux, we might call it, we'll call that the induced flux, which will, and this is the key part, it will oppose the change in flux. So, we start here. This is where we start. We have caused some sort of a change in flux. Now, we could cause that change in flux in a number of different ways. We might have a magnet that's close to a coil and we're bringing it closer. We might have a coil and we might spin that coil in a magnetic field. Anything that we can do to change the flux through the coil will correspond to this part here. Now, if that happens, then the coil will produce a current. And the direction of that current will lead to its own flux being created, and the direction of that flux will always, without exception, try to oppose the change that we have initially caused. So that is Lenz's law in a schematic or a literary sense. What we're going to do now, we're going to see how that works practically in a range of situations. So that will be our next lesson.